All right, so for today, we're going to be taking a look at combining like terms and the distributive property in relation to rational numbers. So, combining like terms and distributive property, those are review topics for us here in the seventh grade, but we're going to apply them to rational numbers just as a refresher. So, some vocabulary terms review: expression is a mathematical sentence that does not include an equal sign, whereas an equation is a mathematical sentence that does include an equal sign. Like terms are terms separated by addition or subtraction that have the same variable and the same exponents. Constants are like terms, right? So if I have x plus y plus y plus z, those are all unlike terms, so I cannot combine them. It's like having apples, pears, and bananas. Yes, they're fruits, but they're different types of fruits. So I can't combine my apples and my bananas and say I have apple nanas, right? That's just not realistic. Let's just review a few like term examples. So here in the first one, we're going to use shapes to identify our like terms. So z and Z are both like terms, and we want to circle those signs because we work with integers and we know that negatives and positives can make a difference in our response. So you want to include the sign with the variable. So this would be rewritten as x plus y plus 2z. Now, if we take a look at the next example, okay, here we have 2x plus 4x plus 3x squared. So x and x would be like terms because there is an invisible exponent of 1. But with the 3x squared, it's a different exponent. So it wouldn't be a like term to those. So our like terms here are positive 2x and positive 4x for 6x plus 3x squared. And we can't simplify that any further. Now, if we take a look at this last example, right, I have two sets of like terms. So my -2 and my +5 are both like terms, and then so are my y's. So if I simplify this, I have y plus y, which is 2y. Now I have a -2 plus 5, right? So different signs subtract, keep the sign of the higher number, so that's a +3. Now let's refresh our memory on the distributive property. It states, multiplying a number by a group of numbers added together is the same as doing each multiplication separately. So order of operations would have told us to say, oh, try to combine what's in the parentheses first and then to multiply. Okay, but the distributive property says to take what's on the outside and to distribute carried over to what's on the inside. So this would be 8 times x and then 8 times 4. So when we rewrite that, that will look like this: 8 parentheses x plus 8 parentheses 4. 8 times x is just going to be 8x. 8 plus 4 is 32. And that would be my final answer when I apply the distributive property to this example. Now let's take a look at this example. Which one doesn't belong? So here, if we look at the first example, I can see distribution, right? So there's a number on the outside. Parentheses denotes multiplication. So this is like 2 times x plus 2. And I can distribute my values throughout. The same thing in the second example, right? It's subtraction on the inside, but I can still multiply that 5 through to the x and the 8. If I look at this third example, though, it's very different. So this 4 is being added to whatever is in the parentheses. And we know that distributive property tells us to multiply what's on the outside through to what's on the inside. So this does not give me a representation of distributive property. Now, if I look at this last one, I do see distribution because, again, it's on the outside being multiplied to the 9 and the negative x on the inside. So which one doesn't belong? This third one, because distributive property implies multiplication, and here the number on the outside is being added to what's inside the parentheses. All right, so now let's take a look at some rational numbers where we're going to apply distribution as well as combining like terms. So the process is the same. I'm going to distribute this number on the outside through to everything on the inside. And I'm going to rewrite this as negative 3.2 times negative 4 plus negative 3.2, and I'm going to put the second one in a parentheses. I can put the first one in a 2 just so that I'm uniformed. And then that's being multiplied to the 5. Okay. Now, as you know, that whenever we have the same signs being multiplied, the answer is going to be positive, right? So 3.2 times 4 is 12.8. You can do the math. And the number is going to be positive because it's a negative times a negative. Now, when I look down here, I'm going to just bring down this plus, but I have a negative 3.2 times a positive 5. So negative times a positive is going to be a negative 16. Okay. Now, if you notice here in the middle, I have these two signs. I have a plus and a negative. So different signs, that's going to make this negative. So I can rewrite this as 12.8 minus 16. And then when I subtract, okay, different signs, subtract, keep the sign of the higher number. So my answer is negative 3.2. So if you noticed in this one problem, we had operations with decimals, we had multiplying integers, and adding and subtracting integers. Okay, so let's take a look at this next example. So here I have fractions, and when I rewrite my whole numbers, I'm going to turn them into fractions just so it's easier for me to work with. So I'm distributing this negative 1 over 8 through to the negative 2x and the negative 1, everything that's inside the parentheses. Okay, now I'm going to use some parentheses throughout to keep my work organized. So negative 1 over 8 times negative 2 over 1x. And I'm just going to group this in a parentheses. And then now I'm going to write plus. Okay, I know it says minus here, but I'm going to keep that minus with the 1. So I'm just going to write plus here to represent that this is negative 2x plus negative 1. It does not change the value of the equation. Okay, so let's go ahead and write negative 1 over 8 times negative 1 over 1. Okay, now let's go ahead and simplify. So negative times the negative is going to be a positive, okay? And we know that when we're multiplying fractions, we multiply the numerator with the numerator, denominator with the denominator. So 1 times 2 is 2, 8 times 1 is 2, and I'm bringing down my x, bringing down my plus sign. So I have now a negative times a negative, which is going to make my answer positive. So I'm just going to write it here. 1 times 1 is 1, 8 times 1 is 8. So here I have two positives, so I know that's going to remain positive. So here I have 2 over 8x plus 1 over 8. And that's my final answer because I cannot simplify it any further. These are unlike terms. There's a variable here. I cannot combine this with this number. So this is my final answer. All right, let's take a look at this next example. So here we're going to apply the distributive property just like we did in our previous examples. And I will show you once again how to multiply decimals, but I'm not going to spend a lot of time on that because we have had that conversation in the past in previous videos. Okay, so let's go ahead and apply the distributive property. So 5.9 times 11, we'll write that as 5.9 times 11 minus 5.9 times 3.7x. Okay. So now we're going to actually go ahead and multiply. So if you need to see what this looks like, I'll do the 5.9 times 11, and I'll do that right here. So 1 times 9 is 9, 1 times 5 is 5, placeholder, and I have my 9 and my 5 again. Now I'm going to just go ahead and add these numbers. Okay, so I have 649, and then now I need to count the number of decimal places that I have. I only have one, so the product here is 64.9. So 5.9 times 11 is 64.9. And then 5.9 times 3.7 is 21.83. Don't forget to bring down the x. This is my final answer because these are unlike terms. I cannot combine them. Now let's go ahead and take a look at the next example. So here, if you notice, the distribution would only apply to the a and the 5 because the minus 2a is not inside the parentheses, and that now is just a second part of the problem. So here, 6.2 times a, we'll write that like this, and then 6.2 times 5. And then we're going to just bring down the rest of the problem. Okay. Now we're going to go ahead and multiply. So 6.2 times a, we can just rewrite that without the parentheses. And then 6.2 times 5 is 31. And again, I'm bringing down the rest of the problem. Okay. Now I can identify my like terms. So I see a 6.2a, again, like terms, same variable, same exponent, and then my negative 2a, and then my positive 31 and positive 1.2 are also like terms. So now I can go ahead and simplify. So 6.2a minus 2a is 4.2a, and then positive 31 plus 1.2 is positive 32.2. That is my final answer. There's nothing else I can combine, so I leave it as is. So this problem is asking me to write two expressions, sorry. So this problem is asking me to write two expressions, one for finding the perimeter and the other for finding the area. So first I need to think back. So here this question is asking me to find two things. It's asking me to calculate the perimeter and the area of this rectangle. So before I can even get started, I have to think back, how do I find the perimeter of a shape? If you said to add all the sides, then you are correct. So for perimeter, it's the sum of all sides. Okay? And now if you look here, we only have two sides that are given to us. But based on what we know about rectangles, we know that alternate sides are equivalent or congruent. So if this side is 2x, then this side will also be congruent to that. So if this side is 2x, then this side will also be equal. So 2x and 2x. And if this is 2x plus 7, then up here is 2x plus 7 as well. These symbols just represent congruency. So here, it's telling me that this side is congruent to this side, and then this side is congruent to that one. So let's go ahead and add these up. So I have 2x plus 2x plus 2x plus 7 plus 2x plus 7. And now I can go ahead and combine my like terms. So I have 2x, then a positive 2x, positive 2x, positive 2x. I forgot to include my plus sign here. Okay. And then I have a positive 7 and a positive 7. So we can go ahead and combine those terms. So 2 plus 2 is 4, 4 plus 2 is 6, plus 2 is 8, so this gives us 8x, and then 7 plus 7 is 14. That is the perimeter of this shape. Now let's figure out the area. So area is length times width. So A equals length times width. So we can say that this is our length and this is our width, and we can substitute those in. So A is equal to 2x times 2x plus 7. And here I'm going to apply my distributive property. So 2x times 2x, and then 2x times 7. Now you should remember that when you multiply a variable times a variable, that becomes squared, right? So anything times itself can be represented using squared. So 2 times 2 is 4, x times x is x squared. And then 2x times 7 is 14x. The area is 4x squared plus 14x. Whatever the units are, we don't know. But if we did know the units, it would be units squared. Thank you for watching and have a wonderful day.